swings. They have identified one possible culprit: volcanoes. Ironically, this clue came from deep in the ice. Lonnie Thompson is a glaciologist who specializes in plotting the history of our climate by studying ice cores.
Ice is like a time machine in that it records the history of the past, and the deeper you go, the further back in time you go. You can look at the 20th century, but you can look at thousands and thousands of years of history.
Thompson has collected cores from all over the world. His impressive collection is kept at -30 degrees in his cold room in Ohio.
These cores come from the South Pole in Antarctica. These are Bonar Churchill from southeast of Alaska, Kilimanjaro from Africa, Dai 3 in southern Greenland, Huascarán from the Andes of South America. These are cores that come from around the periphery of the Greenland ice sheet.
What makes the ice cores so useful to climatologists like Thompson is that they absorb and perfectly preserve chemicals and particles in the atmosphere, allowing scientists to record ancient atmospheric composition and discover what natural phenomena occurred at the time.
You can see when we put lead in gasoline. You can see when we passed legislation to take the lead out of the gasoline. So they're a very good recorder of anything that's in the atmosphere.
They can preserve sand and dust from years of drought.
The beauty of the ice is that this dust is preserved as it fell. It represents a drought that occurred in Africa 4,200 years ago.
They also preserve dark layers of volcanic ash. Dotted around Thompson's cores are the records of volcanic eruptions.
So if you look at these, you can see the eruption of Huayna Pechina from February 17th, 1600 AD.
By measuring the concentrations of atmospheric gases and the radioactive isotopes trapped within a layer of ice immediately after the layer of volcanic ash, Thompson is able to determine the climate dating to that year. He discovers that after major eruptions, the temperature drops. Somehow, the big eruptions are triggering sudden coolings. Erupting volcanoes fire vast quantities of ash into the atmosphere. This ash is made of such tiny particles of rock that it floats on the wind. Traveling around the globe, it forms a blanket high in the sky, cutting down the sunlight and cooling the planet below. The ash then falls to Earth to be trapped in the ice cores. By dating each layer of ash in the core, Thompson is able to build up a picture of what happened to the climate after each eruption.
1815, the eruption of Tambora. Indonesia volcano led to the year without a summer.
In Europe, the summer temperatures were 5 degrees lower than normal. Wheat crops failed, and thousands of people died of famine. Even the USA was affected.
Here in Ohio, we actually had snow in July during that summer. No crops were produced. So these volcanoes can have a very immediate impact on the climate.
Scientific analysis of the ice cores reveals that the volcanoes affect our planet's temperature in several ways, because volcanic ash from eruptions is not the only cause of a sudden freeze. Volcanoes have another weapon. A gas that can actually reflect the energy from our only heat source, sunlight, back into space. Along with the ash cloud, volcanoes pump a cocktail of gases high into the atmosphere. Volcanologist Dave Schneider analyzes these gases by flying over the craters of active volcanoes. His laboratory is the state of Alaska, the most volcanically active area of the United States. Today, Schneider is flying to Mount Spur, an active volcano that has been smoldering over the last year. He will fly directly over Mount Spur's crater and through its gas cloud.
Cherry 357, where are you going? We're going to Mount Spur. not overtake.
The horizon is littered with volcanoes. Schneider knows them all.
There's a lot of beautiful volcanoes in Alaska, and one is more interesting than the next, and it's hard to come up with. It's like asking which of your kids do you like the best.
After an hour, they arrive at the simmering volcano.
And right now we're just flying over the caldera rim from an eruption, tens of thousands of years ago, formed a large caldera at the summit. And then the new summit here is a volcanic dome that has grown in that crater afterwards.
In his airborne laboratory, Schneider gets down to work.
What was our altitude at right there, Ron?
82 right now. You want a little bit lower?
Schneider is analyzing the volcanic cloud for clues as to how it alters the weather. It doesn't take long for him to find the volcano's secret weapon, the gas sulfur dioxide.
There's a faint odor of sulfur dioxide that you can smell as we fly by, just pulling it in from the air vents. That's exactly what we're trying to measure here.
When it comes to global cooling, sulfur dioxide is the most damaging of all the volcano's gases. Big eruptions blast sulfur dioxide high into the upper atmosphere, where it reacts with water vapor to form droplets of sulfuric acid.
Sulfuric acid droplets are very shiny, much like this mirror, and they reflect the incoming sunlight back up into space, which would have the net effect of cooling the Earth.
Imagine billions of tiny mirrors floating above our planet, reflecting the sun's light back into space. Far less sunshine reaches our planet, and temperatures drop. The effect of sulfur dioxide is so powerful that even non-explosive eruptions, producing little or no volcanic ash, can drastically affect climate. In 1783, Mount Laki in Iceland started to ooze sulfur-rich lava from cracks in the Earth's surface. It produced no ash, but lots of sulfur dioxide. This caused the average temperatures in the eastern U.S. to fall over 9 degrees the following year. But are these temperature hiccups triggered by volcanoes big enough to seriously affect life on Earth? Some scientists suggest they are. In fact, a volcanic eruption almost 1,500 years ago changed the weather so radically that it may have altered the course of human history. Historian David Keyes thinks a colossal eruption in 535 AD entombed our planet within a cloud of volcanic gas and dust.
A lot of the accounts from the period actually say that the sun shone like the moon for a year.
The drop in global temperature had huge and surprising side effects on societies around the world. Old empires were destroyed and new ones flourished. The world we live in today emerged out of this global chaos.
It was a catastrophe and hugely changed the demography and the society of large swathes of Africa, the Middle East and Europe, and as a direct result in that, changed history.
The sudden drop in temperature triggered by volcanic eruptions produces complex effects. It wrecks the delicate balance of our daily weather patterns. A climate change of just a few degrees could send weather tumbling out of control in many parts of the world.
Massive storms, droughts, floods, that sort of thing. Really, it's these extreme weather events, which are the business end, if you like, of climatic problems.
Just imagine if every year our cities are pummeled by hurricanes, countless floods, and by tornado after tornado. Triggering such extreme weather events could kickstart an unstoppable chain reaction that leads to global catastrophe. It's a bit like a set of toppling dominoes. The first domino to fall would be climate change, which could cause more violent weather in parts of the globe. This weather chaos causes crops to fail, which leads to famine and starvation, and then disease. And once dominoes start tumbling, nothing can stop them. Next comes civil unrest, the collapse of a society's infrastructure, and eventually, total anarchy. But there's a twist in the climate change tale. It could affect different countries in different ways. Some scientists believe that the most advanced societies will feel the effects the hardest. They argue the more developed the society, the more there is to be broken.
The higher you go, the further you can fall. So if you have a society that's very, very complex and very sophisticated, it's very, very vulnerable if things go wrong.
Less advanced cultures, although still affected, don't have so far to fall. They could suddenly find themselves able to compete with previously dominant cultures on a more equal basis. The result could be a realignment of political and military power, a free-for-all that often leads to war.
It's a bit like a sort of grand game of geopolitical musical chairs, where suddenly you get climatic problems and their repercussions, and everybody has to swap round a bit.
Keyes believes that it doesn't require a huge climatic event to trigger one of these reshuffles. Even small changes could have an effect.
Climate change has the effect of resynchronizing history. And it's done that in the past, and I've no doubt it will do it in the future.
Volcanoes can cause devastating cooling, but the effect only lasts for a few years. Imagine a giant freeze that lasts for 1,000 years with the power to wipe out whole species. Such a dramatic freeze happened 13,000 years ago. Now, some scientists are worried that parts of the planet may face another cooling in the near future. History has shown that even small changes in the climate, sometimes of no more than a few degrees for a few years, can change the course of civilization and push societies to the brink of disaster. But what would happen if the change in the climate was long-term and much more severe? Could it have the power to wipe out a whole species? The answer may lie deep below ground in the Great Saltpeter Cave in Rockcastle County, Kentucky. Anthropologist Kenneth B. Tankersley studies sudden climate change by examining fossils. His research may shed light on the power of the weather.
What we find here, I think, can help us adapt to future climatic change. Literally, our survival may be in the sediments within this cave.
Tankersley leads a team deep underground, hunting for evidence of a sudden climate change that took place at the end of the Pleistocene period, 13,500 years ago. This cave is packed with the remains of animals that died thousands of years ago and were washed underground.
Caves are environmental magnets. They collect plant and animal remains primarily because caves function as Mother Nature's sewers.
The constant temperature and humidity in the caves preserve animal bones in sediment layers, one on top of another, perfectly filed in chronological order.
We go deeper and deeper in the cave. We're going further and further back in time. I've often thought that if I walked just a little bit faster, I could actually catch up with the people and the animals that lived during the last ice age.
Tankersley's team worked their way deep into the cave system. They're searching for fossils. Accumulations of fossil bones and plant material in caves are called middens. They are a good indicator of how changeable our climate has been in the past.